This video is for IB Chemistry 2. It's on calorimetry, which can be found in Chapter 5 of your textbook on page 179. And if you read that until about page 181, this will work through all the practice problems you should do. So if you're looking for more help than what's covered in the video, I would suggest reading pages 179 to 181 to give you a further understanding. But to introduce you to calorimetry, calorimetry is studying the heat of reactions, and you have to remember that heat, which is Q, cannot be measured directly. You have to calculate it. And in order to calculate heat, you need to know a few things. Now, I'm going to ask you to think about a scenario in which I take two quarters, assuming that they are identical mass and identical chemical makeup. And if I hold both of them in a Bunsen burner for, say, 10 seconds, they're both going to absorb heat. Now, if I drop those quarters, one into a Dixie cup, a small container of water, the other into a large bathtub of water, both of them will lose heat to the water, but the water will not necessarily warm up in the same way. You won't notice a temperature change in the bathtub, but you might notice a temperature change in the Dixie cup, and that has to do with mass. So there's some things that can go into calculating heat. So we already know some variables here, but I'm just going to have you write this formula down. The big formula you need to remember is that Q, heat, is equal to M, which is mass, times the delta T, or change in temperature, times a quantity we call C sub P, which I'll explain to you what that is in just a moment. So you already know Q is heat, and we usually measure heat in joules. We also may use calories. And if a problem was given to you in kilojoules or kilocalories or any other unit than joules, you would have to do a conversion to get it. You want Q to be in joules. We know that mass is measured. Now, in this particular problem, mass is in grams. So remember that mass is in grams in this case. Delta T is the change in temperature, so it's the final temperature minus the initial temperature. And that will be in degrees Celsius, or it could easily be also in degree Kelvin. And I think some students really struggle with this, but let's use an example. If I say my initial temperature is 0 degrees Celsius, and it's going to gain heat, and it's going to warm up to be 10 degrees Celsius. Okay, I think we can all agree that the change in temperature, final minus initial, is 10 degrees Celsius. It changed by 10 degrees Celsius. Now, if I were to do that on the Kelvin scale, 0 degrees Kelvin is 273. 10 degrees Celsius is 283. And so the change in the temperature is still the same amount of change. It's still 10 Kelvin degrees. So the change in temperature could be in degrees Celsius or in degree Kelvin. And then that last quantity there is the new one for you. That stands, CP stands for specific heat capacity. And that has a complicated label of either joules per gram degree Celsius or joule per gram degree Kelvin. And hopefully you understand that changing a degree Kelvin is the same as changing a degree Celsius. So what is specific heat actually measuring? Well, specific heat has a definition that says the amount of energy needed to raise the temperature of 1 gram of whatever that substance is 1 Celsius degree. Now that should sound familiar to you. If it does, you might look back in your note packet and see that that's very similar to the definition for the word calorie. The only difference in the word or the definition is that in calorie, the substance we're talking about is definitely water. And in specific heat, it could be any substance. So we know, hopefully you figured out, that the specific heat for water is either 1 calorie per gram degree Celsius or 4.184 joules per gram per degree Celsius, okay? If you wanted to know the specific heat of any element, you would look it up on your periodic table, and it would be listed under the key, so you'd have to look for it. Specific heat capacities of all the different elements are listed right on the periodic table for you. Now, important information to understand. The heat will have a negative value when heat is lost. And if you think about it, heat would be lost when the temperature goes down. So if you start at, say, 30 degrees and decrease your temperature to 25, your delta T would be negative because your final would have been 25, your initial would have been 30, and your change is 5 degrees Celsius, negative 5. So when Q is negative, that means heat was lost. Now, if you gain heat, your temperature is going to go up, and so you'd have a Q that is a positive value. So I want you to think about those things as we try some of these problems. Nothing about these problems is mathematically that difficult. You have a variable, you have a 4 variable equation. As long as you know 3 of the 4, you can find the missing one. So we're going to practice this very first question. It says, large beds of rocks are used in some solar heated homes to store heat. Assume that the specific heat of these rocks is 0.82 joules per gram degree Kelvin. Now, in A, I want you to calculate the quantity of heat absorbed by 50 kilograms of rocks if their temperature increases by 12 degrees Celsius. Now, I'm going to go about this really obviously, okay? And for some of you, you'll probably skip some important steps, but eventually you'll get to the right answer. I just want you to be real obvious about this. So I'm asking you to find heat. That's what I'm looking for. I know that the mass of these rocks is 50 kilograms. However, in my formula, in order to be able to use this, it has to be in grams. So I'm going to convert this to grams by multiplying by 1,000. So 50 kilograms is the same as 50,000 grams. I know that their temperature increase, or the change in temperature, is 12 degrees Celsius. Okay, and I know it's a positive 12 because the temperature is increasing, it's going up. And we are assuming, according to the original statement, that the specific heat of these rocks is 0.82 joules per gram degree Kelvin. Now, I'm asking you to find Q. And so we know that the formula says Q is equal to M times delta T times Cp. So the mass that I want to use in this problem is 50,000 grams. The temperature change is 12 degrees Celsius. And the specific heat capacity was 0.82 joules per gram degree Kelvin. Now, if you look at your labels, the grams will cancel out, and that's pretty obvious. But you have to remember that changing 12 degrees Celsius is the same as changing 12 Kelvin degrees, and so those actually really do cancel. So all that is left is doing your math and worrying about how many significant digits you have. Now, since the specific heat was the fewest at 2 significant digits, my answer can only have 2 significant digits. And you get about 4.9 times 10 to the 5th joules, or you could write that in kilojoules as 4.9 times 10 to the 2nd kilojoules. Either is fine. They both mean the same thing. Most often, you'd just leave it in joules, but if the question were to ask you, you could easily convert that. So that's using the formula to find Q. Now in part B, which is your learning check that I'd like you to complete in Moodle, I'm going to ask you to find the temperature change that the rocks would undergo if they emitted 450 kilojoules of heat. And I want you to think about what should the signs be of that Q and therefore of the delta T. What should the signs be if heat is emitted? And if you don't know what emitted means, you should look it up. All right, good luck.